Hello there, it's Richmond here, and I welcome you to the fourth episode of the Xplore Bot series. In this particular episode, we are going to look at how to build and program the obstacle avoidance robot. Yes, the obstacle avoidance robot. I'm sure you are wondering what an obstacle avoidance robot is. An obstacle avoidance robot is basically a robot that is able to see an obstacle in front of it and avoid it whilst it's moving, right? And so I have here with me my Xplore Bot, which is a 4-wheel drive, and you can also use the 2-wheel drive as well. Next, I have the ultrasonic sensor. This is the sensor that is going to allow my robot to view the obstacles in front of it and then avoid it, right? Also, it comes with its holder and also some connectors for attaching it to the Xplore Bot. Now, since we would have to connect the ultrasonic sensor to the robot, we need to use a jumper wire. This one here is specifically the female to female jumper wire. Lastly, we have our uploading cable. After building the obstacle avoidance robot, we would have to program it, and so the uploading cable here allows us to do so. All right, so to get into this, the very first thing we are going to do is to do the connection between our Xplore Bot and also the ultrasonic sensor. And so I'm first going to pick the ultrasonic sensor, and as you can see, the ultrasonic sensor has 4 pins, right? These 4 pins, we have the VCC, which is the positive terminal of the ultrasonic sensor. We also have the GND, which is the negative terminal. Now, these 2 pins are being paired to power the ultrasonic sensor. Aside that, we also have the trigger pin, which is used to control the trigger section of the ultrasonic sensor, and also the echo pin, which is used to control the echo section of the ultrasonic sensor. And I'm sure you are wondering what the trigger and echo is. Now, let's look into the physics of the ultrasonic sensor. For the ultrasonic sensor to get the distance between it and the nearest obstacle, it fires an amount of sound waves. These sound waves travels, it hits an obstacle, comes back, and then the ultrasonic sensor receives it, gets the time that the sound wave used to travel, and using some formulas, it's able to get the distance the sound wave traveled, which is equal to the distance between it and the nearest obstacle. And so the trigger here is the one that fires the sound waves. So it's more or less like the output that fires the amount of sound waves that travel. Okay, and then the echo here is the one that receives the sound waves after hitting an obstacle. And so you have it. That is the basic explanation to the various features of the ultrasonic sensor. Now, once we have that out of the way, let's move on to connecting the ultrasonic sensor. All right, so I'm going to unfold my jumper cable. As you can see, it is a female to female jumper cable, right? And so the very first section is going to go to my ultrasonic sensor, and then this section is going to go to my robot. So let's first learn how to connect the first part of it. Okay, now if you take a look at the jumper cable this way, you would see it has the red wire. Now let's focus on the red wire. The red wire is going to represent our positive terminal. So you look at the part that the red wire is connected to, and then you connect that part to the VCC of the ultrasonic sensor. Now, once you have that one done correctly, then that means the other cables are also going to connect automatically. So let's do that. So I'm going to connect the red section to the positive side of my ultrasonic sensor, which is the VCC. So I connect it this way. Now, once I have it this way, the other pins, which is the trig, the echo, and the GND, are also going to be successfully connected. All right, so as you can see, I have that done. The next part is the section that goes onto the Xplore Bot. Unfortunately, the Xplore Bot has a dedicated port that you connect your ultrasonic sensor, and so you don't need to think much, right? Okay, so to do that as well, you need to focus on the positive terminal. Now you focus on the positive terminal and also look for the positive terminal for the port dedicated for the ultrasonic sensor. Now here is the port for the ultrasonic sensor. If you pick your Xplore Bot, the ports dedicated for the ultrasonic sensor are the male headers positioned here. So as you can see, we have some male headers positioned here, and that is where this female header is going to go, right? So I'm going to focus on the positive and look for the 5 volt or the VCC of the port dedicated for the ultrasonic sensor and align it with the positive, which is the red part of the jumper wire. So I'm going to connect it this way. Now once it's inside, make sure you press on it to make sure that all the pins are connected or fitted well. So as you can see, I have this part also connected very well. Alright, so at this point, as you can see, we have our ultrasonic sensor connected to our Xplore Bot using the jumper cable, right? Now, this here is the ultrasonic sensors holder, and then we have some connectors to connect it also with the Xplore Bot. At this point, we are not going to connect it yet. We are going to first work on some few projects with the ultrasonic sensor before we connect it with the holder to the robot. All right. Now, without wasting much time, let's work on the first project for the ultrasonic sensor. And that project is basically reading the ultrasonic sensor values and displaying it on a serial monitor. I'm sure you are wondering what a serial monitor is as well, right? Now, a serial monitor is basically a monitor inside the Xplore IDE that allows you to perceive or view whatever that is being processed on the Xplore brain, right? So think of it as a place where you can actually ask the microcontroller to display its data or its output, right? So in this particular scenario, in order to be able to validate that our ultrasonic sensor is reading, we can actually program the Xplore brain to actually receive the values from the ultrasonic sensor and display it or send it to the serial monitor via a serial communication port. All right. And so that is the first project we are going to work on. So let's connect our Xplore Bot to our laptop using the uploading cable. So I'm first going to connect this section to my Xplore Bot. Make sure it is connected very well so that you can have it showing on your Xplore IDE. Next off, I'll connect this to my laptop. So let's go to my laptop. All right, once I have my Xplore Bot connected to my laptop, the next thing I'm going to do is to connect it on the IDE as well. So I go to the bottom right corner, click on the connect button, and I'm going to see the USB, which is the port through which my laptop is going to communicate with my Xplore Bot, right? If you are unable to identify that, just disconnect the Xplore Bot and check in the list the one that disappears and reconnect your Xplore Bot to see the ones that adds up to it. That is the one dedicated for your Xplore Bot. Then you select that. Also note that if you are using a Windows machine, it's going to come as a COM with a particular port number. All right. So this is mine. I'm going to click on it. And this green section over here shows that it has been successfully connected, right? So I'm first going to write the program to receive the data from the ultrasonic sensor and display it in the serial monitor, right? So I'm first going to use an event which is going to trigger my Xplore Bot to start executing the program that I want it to execute. In this particular project, I'm going to use when Xplore starts. So immediately the Xplore Bot is booted up, I want it to start executing the program. The next thing I'm going to do is to create a container that is going to store the values being read from the ultrasonic sensor. And in programming, we call these containers variable. So any container that has a name and it's able to store data is what we term as variables, okay? And so I'm going to go to the variables palette and I'm going to click on create variable. Now, once you click on create variable, you need to identify or type in the name of the variable that you are creating. And always, I would advise you to use a name that corresponds to what the variable is going to contain, all right? And since mine is going to contain the distance of the ultrasonic sensor, I'm going to name it distance, right? So once you type the name, you can click on OK. So next off, you are going to see all these blocks here. And the set block is the very first one, which allows you to set the variable to a value, right? So if you want to set the variable to any value, you can use the set block. Now, the change block is going to allow you to add onto the current value of the variable or subtract from the current value of the variable. Then we have this last block over here, which allows you to get what is inside of the variable, right? To read whatever is in the variable. Now, I want to set the variable to what has been read from our ultrasonic sensor, okay? And so I'm going to pick a block that reads data from the ultrasonic sensor. And since it's a sensor, I'm going to go to the sensors palette and we are going to see this first block here, read distance in centimeters, right? So I select this block and then I connect it right here, right? I connect it right here. So this basically means that I'm setting the distance variable to the value that has been read from the ultrasonic sensor, specifically in centimeters, right? Now, after reading it and storing it in the distance variable or setting it to the distance variable, I'm going to now go ahead and display it on the serial monitor, okay? So I'm going to display it, and to display it on a serial monitor, I'm going to go to the basic palette and I'm going to find here print to serial, right? Now, this print to serial, by default, it is printing a string hello, right? And that is not what we want to display. We want to rather display or print on a serial monitor what has been read from the ultrasonic sensor, which is being stored in the distance variable. So I'm going to go back to my variable and then select the distance container here and then put it right here. So finally, this is going to mean that whatever has been read from the ultrasonic sensor, which has been stored in the distance variable, should be what printed to the serial, okay? Now, we are not going to end here. We are going to add one last block, and that block is going to allow us to repeat it forever, okay? If you run it this way, it's only going to run once, and then you are not going to really see the effect. But since we want to actually see the continuous reading of the ultrasonic sensor, we are going to put it in the repeat forever loop. So I'm going to go to loops, and I'm going to pick the forever and drag and drop all these inside the forever. Then I can finally connect it to my event. All right, so if I run it this way, you are going to see the values of the ultrasonic sensor being displayed on the serial monitor at a very fast rate, right? So let's run it and see. So I'm clicking on the play button to run it. And currently, I'm going to open the... So next, I'm going to open the serial monitor, which is at the bottom here. And as you can see, the ultrasonic sensor is reading the distance. Currently, the distance being read is between 83 and 84 centimeters. Now, if I bring my hands closer, you will realize that the distance is being reduced. So let's do it this way. So I have my ultrasonic sensor here. Currently, it's reading, let me put my hand here so that we get that reading accurate. So it's reading between 40 and 30. Let me bring my hand closer. So as you can see, as my hands get closer, the distance also reduces, right? As my hands get closer, the distance reduces. Now, if you don't want the distance to be changing at a very fast rate, you can put a wait block there. So I'm going to go to the loops and then I'll look for weight. Now the weight, I'm going to use a very small weight in between there, which is 0.2 seconds. And I'm going to upload this code again. Now let's watch how the distance is being displayed on the serial monitor. So as you can see at this point, the distance is being displayed at a much more slower rate. Depending on your weight, you're going to even get it more slower. Okay, so I'm going to bring my hands closer, right? And you can see the distance is reducing slowly. Great. So at this point, we are done with the very first project with the ultrasonic sensor. We are going to move on to the final project, which is the obstacle avoidance robot. And I'm sure you can't wait to see that. So let's dive into it. So first off, I'm going to have to connect my ultrasonic sensor on my Xplore Bot. Okay, so I'm going to connect it using the holder here, the ultrasonic sensors holder. So connect it this way, right? So you make sure everything is inside very well. Okay, then I connect my connectors to this side of it. So you can actually use just two connectors. So one on this side, then the other on this side. So at the end of the day, you have something like this, right? Something like this. Now, this particular ultrasonic sensor is going to go in front of the Xplore Bot this way. So I'm going to pick my Xplore Bot this way and then put my ultrasonic sensor in front of the Xplore Bot like that. So put it in and you can see there is a connection here. You can just snap it in like that. So at this point, you can see I have my ultrasonic sensor connected to my Xplore Bot. So once I'm done with that, I can go to my program and do some changes to the program and you'll get the obstacle avoidance robot. All right. So we are going to continue from where we ended here, right? Now, mind you, anything inside here is being repeated forever, okay? So we are going to continue with the things inside the forever loop, okay? So after printing the distance to the serial, we want the robot to do something, right? So we want the robot to maybe start moving until a particular condition is met, right? So we are going to go and use a logic, right? So you can see with this logic here, we are going to have if and else. All right, so we want to check for a particular condition, right? And the condition is, has the ultrasonic sensor gotten so close to an obstacle? And the only way we are going to be able to determine that is by getting the distance between it and the nearest obstacle. So when the distance between it and the nearest obstacle is close, that means it is very. So when the distance between it and the nearest obstacle is very small, that means it's very close to that obstacle. And so we need to make a turn, whether to the right or to the left. Okay, so that is what we are going to do. We are going to check, right, if the distance, which we have it in the variables. So if the distance, now here it is equal to, so we need to change it. So I'm going to make it this way. If the distance is greater than, then I go to math, then I get this particular block. So if the distance is greater than 5 centimeters, right? Then I want the robot to move forward, right? So that means it is not closer to the obstacle when it is greater than 5 centimeters. All right, so here I'm going to use the go forward, four-wheel drive go forward to move the robot forward because I'm using a four-wheel drive. So if in your case you are using a two-wheel drive, you can also change it to that. All right, so I go forward. So with a speed of 60, so I don't want it to go forward with that much speed. So in this else section is going to contain the blocks I want to be executed when the distance is equal to or less than 5 centimeters, right? And when it is equal to or less than 5 centimeters, that means the robot is actually closer to the obstacle. And so I need to make a turn whether to the left or to the right. In my case, I'm going to turn towards the right. So I'm going to pick the steering block, which is also under motions palette, and the four-wheel drive. Let's take note. If you are using a two-wheel drive, you can use that as well. So four-wheel drive, steering. Now I'm going to steer hard towards the right, so I'm going to use 100 as my steering, and the speed I want to use 100 as well for the steering speed. Now for how long do I want to steer towards the right? I want to steer for just a second and stop, right? So with this here, the robot steers towards the right and then stops. Then it will check for the condition again. So if it is cleared from the obstacle, then it can also move forward by running the four-wheel go forward, right? So let's upload this code. And I'm going to change the event for this particular project to the when the OK button is pressed. Okay, so let's use that event. Okay, so I'm going to upload this code here to my Xplore bot. All right, so I have my code uploaded. So what I'm going to do is to clear the table and then run the program. So I'm going to put this here and I'm going to disconnect my uploading cable. And don't forget to turn on your Xplore bot. All right, so this is my robot. To actually start executing the program, I need to click on the OK button. So I'm going to click on it. So as you can see, when it sees my hand, it turns. When it sees my hands, it turns. So let's see if it can actually see the obstacle here. It did see it, right? So just as you can see, so this is basically the obstacle avoidance robot. You can actually add more things to it by, adding maybe a buzzer. You can add an LED, so in case it sees an obstacle, it turns on the red LED and then it also sounds the buzzer, or you can make it only sound the buzzer when it sees the obstacle. All right, so at this point, I'm sure you can now program your robot not just to move, but also sense an obstacle in front of it and take a particular decision. I'm sure you enjoyed this lesson, and in the next one, it's going to be even more exciting. I hope to catch you there. Bye-bye.